Hello and welcome to my channel, ATX Architect, where I'm obsessed with making you the fastest architect, designer, and planner on the planet. My name is Brent Hebert, and today I'm going to be building the world's tallest building, the Burj Khalifa, using my secret Revit weapon that I use to create site plan concepts, designs, and presentations that I've been painstakingly developing for years that I call site plan shortcuts. Now, before I get into this, let me give you a tour real quick and show you how you can use this. And if you'd like to get your hands on this, minimize myself here. So this is what it looks like when you download the file and open the file. The link is in the description to grab this. And once you have access to that file, you'll actually get access to this website as well, which will give you a step-by-step interactive video and text on how to use it. I walk you through everything, no matter whether you're an absolute beginner in Revit or an absolute pro. This is going to work for you. You can start from scratch or you can start right here. So without further ado, I'm going to give you a little bit of a tour through this. So when you download this, you're gonna have 4 sample projects in here. Basically, you only have to work on this one sheet. I have everything set up exactly the way that you need it. As you model in these views, your massing and your parking, you're going to get all of this data. You're going to get a wealth of data, high level data, as well as more specific data for each building. You can do multiple buildings, you can do one building, you can do tall buildings, you can do any type of project that you want. And you can switch back and forth between plan and 3D and section and all of that good stuff. On top of that, when you're working in this view, in the background, automatically there's going to be a presentation that's created, 11 by 17 format presentation that also comes complete with these views and this wealth of data here, broken out into different chunks. So you can see kind of the data any way that you want, depending on which sheet you're on. And you really don't have to touch these sheets at all. These are set up no matter what scale. You control your scale of all of the drawings through here. If they fit in this box, it's going to work well with your presentation. As long as you change the scale here and here and make them match your 3D, your plan need to match. If you change the plan, it changes the section scale as well. So it's all connected and you don't have to do much else. So without further ado, let's get into designing a massing model for the Burj Khalifa here. First things first, I'm going to set my design option to option 1, and that's actually where we're going to get started. There's a few things that you want to look for online when you're looking at a building like this. Turns out there's quite a lot of information online. The first place that I go when I'm starting a project like this is I go to CAD Mapper. This is a free tool, free website that you can use. You can type in the address of your project. I just typed into Burj Khalifa here. I turned off 3D buildings and turned off topography, left everything else the same, made this AutoCAD, and basically just zoom in. If you zoom too far out, you're going to see you won't get a free file. You'll have to pay, but usually free is fine. Something like this probably works. You can just create file. This is essentially just going to give you your line work. It's going to be rough line work. It's not going to be perfect, but in this example today, all we need is rough line work. So you're going to get something that looks kind of like that. It's really all that we need. You can go ahead and download that. I've already downloaded the one that I want to use for this, and that's that. The other thing is I have Google Earth open. Turns out they have quite a nice model on Google Earth. If we need to have a reference for proportions and guys, just generally how this building is laid out. Now, while I have this view open, you can kind of see we have these mechanical spaces on this building that split this up, and essentially these balconies spiral up. You can see the balcony here, they spiral up, and it essentially splits these areas into thirds. So whatever amount of floors between these, we split it up into thirds. That's how we know where our balcony is. So if this is 30 floors here, every 10th floor is a balcony. Other thing that I did is I found a couple of images online that will help us kind of generally get a sense for what different types of uses are in this building, and we're going to use that to go ahead and build uses into this as well. I also threw a couple of notes on here to say, okay, in our version of this, because there's split level things going on here, we're not going to worry about any of that for now. We just want to see, there's 21 floors here. We'll divide that by 3. That'll give us 7 floors between each balcony, etc., all the way up, and we have a couple of reference floors there. The other thing that I have is a full-on floor plan of the ground floor here, And so we know kind of which side is the hotel, residential, and office. I kind of have a good sense of all of that, and I think that's going to do it for that. So what I want to do first, I want to bring that AutoCAD that I downloaded from CAD Mapper in. With that, you do that insert link CAD. I always like to link it, is better for me. And if we go here, so we want to make this meters, black and white. You're not going to be able to change that here. We'll change that later. DXF, everything is fine. Let's click open. All right, there it is. Actually, before I do that, we need to set our, there we go. Now we'll make the CAD. Now we'll bring this in. Cool. So, now that we have this in here, we have it on the correct design option. I'm going to make this level 1. Perfect. We can close this view. We don't need it again. So the next move is actually to take this CAD and move it inside of here. Looks like this view is already scaled quite nicely to fit within the bounds. That means our presentation in the back is going to look good. Actually, let's go to the cover here. That fits on there. That's decent enough. Okay, good. That looks good. I think we're basically ready to dive in. I'm going to start off working in this view here. Now, if I open this up, north is facing out this way, which means this leg is this leg in here. So I'm going to build this. This whole building is kind of in thirds. So I'll build 1/3 of it and kind of mirror it around, and we'll go from there. It looks like we're going to say that this kind of portion is hotel for the sake of time here. So I'm going to create a hotel massing on this side. Now, using site plan shortcuts, we use a couple little tricks here that you're not going to find anywhere else. In fact, you'll find it nowhere else on the planet probably. I use ceilings to create these massings because I want things super fast. So what I'm going to do is draw my first axis, and we're going to just kind of throw it in there like that. That is our first leg. Looks kind of wrong. Looks like something you might find in a sex shop or something like that. Another good little tip here is you can actually move your floor plan and where it's cut by moving these sections, because this is actually a section over here, not a floor plan. So it just makes it really easy to move and navigate around this view. I like it, it's quite nice. So let's see proportionally, this is 40 feet. 40 feet looks kind of good proportionally, I think. You know, I might actually want to make this 50. Hotel 50, yeah, let's try that. Okay. Now we simply mirror this. We have our axes already. Mirror this as well. There we go. Okay, so this is our hotel side. If we look at our plan, I think our office side is going to be over here. So let's take this office, and I believe we did 50 feet if I'm not mistaken. These are all pre-built into here. These families are pre-built into here. So we have hotel, office 50, and this will be our residential 50. Nice. Okay, now that we have that, we can see we've got some information here. Some data on the project is starting to populate. That's good, that's what we want to see. You're also seeing kind of the breakout here, total square footage. We haven't set an efficiency for this yet. We'll do that when we're actually complete with this project. You know, acres is set. I'm not going to worry about any of that really for now. I'm going to actually take this CAD and move it up so that we can see it. I guess both the section cut and the CAD, we're going to move that up just briefly here, and there we go. So the next thing I'm going to do is copy this up to the second floor. Yeah, that looks good. Okay, and instead of changing levels on here, it takes a long time to do that. I'm actually just interested in what the floors are scheduled as, so I'm just going to align just like that. There we go. And you know, proportionally, if I'm looking at Google Earth down here, if this base is 50, I think maybe this next bit might be 30, because the base is clearly taller than these two elements here. So let's see, hotel, I'm gonna say 30. Yeah, you can also see based on our section here, this whole thing up here looks like it is dedicated to hotel if you look at the colors legend. So we're gonna say that this is hotel. We're gonna keep that our hotel 30 feet. Good, good, good. Okay. And it looks like, you know, I actually need to move these guys up. All right. So now we can get started. Let's make sure we're grabbing the right element here, and we're gonna chop this up. We're gonna chop this up based on these lines here, and that's what we're basically going to copy all the way up this building to make it work for us. I'm gonna grab this line and use that as our reference line. Cool. All right. So while I'm doing this, I'm actually going to show you guys a video of how this building is designed, why it's shaped the way that it is, and how it actually works.
I'm in Dubai, exploring the Burj Khalifa, the world's tallest building. I want to know how you make something this big in the Arabian desert. A vast sandscape that makes for one of the least suitable skyscraper environments on Earth. To find out, I've met up with Bill Baker, the structural engineer responsible for building the Burj.
No, we're not out having fun. You're looking at two men doing science, because Bill and I have come out to the desert to assess this suitability for building the foundations for the world's tallest building. And my assessment thus far is it's really soft. And it shifts about a lot. Right. So what we've learned from that in-depth and thorough scientific exploration is if I scrape away at this sand for like a really long way, is a sort of a big lump of granite that you can anchor your building to.
No.
Problem.
Okay, so we have no bedrock here. Okay, so under the sand, what we have is ancient seashell dust, a soft material called calcisiltite that was deposited in some ancient ocean. That's what we're sitting on.
But if you're building that high, you need foundations. What are you going to anchor it to?
Say we were working in snow. What would you do?
Well, snowshoe.
Yeah, so that's what we did. We start out with a snowshoe, and I just happen to have with me a model of the base. At the bottom of the Burj Khalifa, the world's tallest building, we have a big snowshoe.
So this is a great big concrete slab.
Yes.
This shape.
Yeah, so it's the size of the building, a little bit bigger.
So that's spreading my weight, so I'm not sinking down.
Right.
But there's a bigger problem. What's stopping it falling over?
Below this, we drilled 194 shafts of concrete into this calcisiltite.
So in the simplest possible terms, it doesn't sink because it's on this giant sand shoe. And these piles, they're still in effectively sand.
Yes.
So the thing that's holding it up,
is friction.
just friction.
Yes.
It seems inconceivable that the world's tallest building is held up by something as simple as the friction generated between 194 concrete shafts driven into ancient seashell dust. But actually, friction is one of the strongest forces on the planet. In fact, the friction is so strong that the Burj Khalifa, all 828 gravity-defying meters of it, is supported by foundations stuck just 50 meters into the desert. But what happens when they're really put to the test? Dubai can be hit by sandstorms and winds up to 100 kilometers an hour, which is a big problem for big buildings. But not necessarily in the way you may think. Cue our hurricane in a box.
Well, let's turn on the wind. So the wind is going this way.
So it's pulling the wind in here.
Yes.
And it's waggling about from side to side. It's not even remotely trying to do
No.
that.
No.
It's going to do that.
Yeah, if a tall building were ever to fall over in the wind, it would probably fall over sideways, not in the direction of the wind. And this is the tall building problem.
When wind swirls around a building, it forms small whirlwinds called vortices. These alternating pockets of low air pressure create forces on the building that can cause it to rock from side to side. Not as much as this, obviously, I've exaggerated it to make a point, but you get the idea.
All skyscrapers have a natural frequency, the rate at which they like to vibrate. Just like this swing, if I push it gently, it'll settle down and settle into its natural frequency. Now the bit where it gets fun, because I have a go. Imagine this swing is the skyscraper, and my legs are the wind. On a perfectly flat-faced, symmetrical skyscraper, the wind can work with that natural frequency to actually increase the rate at which I'm swinging. It's called harmonic resonance.
On a swing, we use harmonic resonance to go higher. But on the world's tallest building, it could cause it to sway more and more until it fell over. To stop that happening, Bill and his colleagues had to design a skyscraper radically different from any other.
This is essentially the Burj Khalifa. The key aspects of this is how the shape of the floor plate constantly changes. As we go up, there's 27 different shapes in the tower, and each of them will generate vortices slightly different than the ones above or below them. So you never get really large forces on the building because they're always coming off at different rates. And because of that, the wind never gets organized. We actually call this confusing the wind.
In order to make sure the wind is well and truly confused, the Burj Khalifa isn't square like a traditional skyscraper. It's Y-shaped. It gets narrower as it rises, its edges are curved, and its cross-section is constantly changing. And this design breaks up the force of the wind.
What the Burj does is what my legs are doing now, which is not working in harmony with the natural frequency of the skyscraper, and as a result, there's barely any swing getting going. Because I've only got 2 legs. The Burj effectively has 27 because it has 27 different levels up its length to break the wind up so it doesn't get organized and establish harmonic resonance. It's good, this. Harmonic resonance, harmonic dissonance.
This slender, asymmetric design has opened the door for future skyscrapers to get even taller.
Okay, so there's that. I find that absolutely fascinating myself. So, I have our first little chunk of this building done, this base of this building. Now this is going to get really tall, so I'm actually going to take one of these section views and move it out here and work with it out here. So on top of that, we're cutting through some awkward spots in this. Let me go back to full screen. I'd rather use these as more like elevations right now. Okay. So that looks pretty good. I know that basically we're just going to copy, paste this to the 3rd floor here. Now the levels, like I said, I don't want to mess with. I want them to stay however they are, because we might have multiple buildings with different levels all over the place. It takes a lot of time to mess with that, so I actually don't want to mess with any levels at all. I really just want the schedule to look right, and I want the floor-to-floor heights to look right. We have little balconies out here we need to get rid of, and you know, that's looking pretty good. So already we have some pretty good stuff going on, and you can see now that we have our 3rd floor, we have office and residential. All of our numbers are kind of working out for us. So I'm going to copy this. Good. All right. I'm liking that. I'm liking that. Let's look at our. We have 1, 2, 3 balconies until we push straight up. So how are we doing? 1, 2, 3. So this is going to be our first floor here, and if we look at our section, this is going to be our first non-taller space here. And you know, I'm going to call this, it looks maybe like 12 feet. I really don't know. One of the things we're going to do here is we're going to test and see, because I know how tall this building is. I know the tallest occupiable floor, which is what we're looking for. We're gonna like just kind of guesstimate and see how close that we get by the end of this. So I'm gonna make this hotel 12 feet, and you know that kind of looks good. I think that's what we're gonna do. So if I go back to my section, it looks like I'm going to copy this up before we get to our mechanical space up here. There are 10 stories, so I really want to copy this up 12 times to get to our mechanical space. Floors are going to be our mechanical space, but you know, for the sake of this video and for this file, I'm going to call this parking. I'm gonna make this garage. Yeah, that looks good, and that's something we want to move up to there. Yeah, there we go. And actually, we're going to copy this up as well. So that becomes our first occupiable floor right there. Okay, so that's looking good. And if we go back again to our section, this next layer right here looks like it's a mixture of hotel and residential. So, you know, we don't know what the exact split is. So I'm going to take maybe about, I don't know, maybe that, and I'm going to make that residential 12 feet. Yeah, okay. Cool. That looks good to me. The other thing that we want to do is say, so we have 21, before we get to this mechanical space, we have 21 stories here. So 21 divided by 3 to get our balconies. That's 7. Every 7 floors up, we're going to create a new balcony. And like I said, the balconies spiral up. I know that the first balcony starts on this leg. So if I go to my 3D view and I pay attention up here to where north is, north is up there. Okay, so our first balcony is officially going to be here. Okay, what I'm going to do is I'm going to copy this up 21 times.
I'm a sucker for the life. I'm caught up in the rise.
Now it's time for our first attempt to spiral these balconies up. So we know we need 7 floors.
I'm a sucker for the life. I'm caught up in the
This guy, that is our next balcony. Right on up there. So what is the use of this next floor up here? So we just completed that second. So this up here, this orange looking residential. So this is fully residential up there. No problem. We're going to go ahead and take all of this and make it residential 12 feet. Alright. Looking good. Next thing we need to do. So this is 30 feet before we get to mechanical. So that means 10 stories, every 10 stories we have a balcony. Let's go ahead and copy 32 stories up if you want to Next move is to create the balconies once again. So remember, we need 10. We need 10 stories between each other. Delete that. So that is what we're continuing up. Looking good, looking good. So the next section of this building up here is this bright yellow. Let's see, this is luxury residential up here. So we went from residential to luxury residential. Well, for this, we'll do some mixing up later on this, so I'm going to, for now, just continue with my residential over here. The other thing that we want to look at This is 33 stories. So before this mechanical, we actually have 11 stories between each balcony. So that's going to be 13 stories. Or sorry, 35 stories total here. And our balconies once more. Area here, and this is going to be a smaller balcony. Now if we go back to our section, we're starting to get into this portion of the building, which is office. And if you notice, it also looks like the floor-to-floor heights are a little bit more. So I think instead of 12 feet, we're going to try 14 feet. Pretty standard office plate. Grab this, change this to office 14 feet. Nice. Looks good. Okay. And you'll notice we also have 24. So if we divide this by 3, this is actually 8 stories. Every 8 stories, we're going to have a mechanical, a balcony. So. At each floor, we have a balcony. Kind of see this is just going to be office kind of all the way up. So this next we have 4 floors. I'm going to call it 4 more floors on top of this. Last little bit up at the top. That's going to be our tower there. Let's see how close that we got. I know that this is the highest occupiable floor here is 1,921 feet. So why don't we just test this out, see how close we got. You know, our guesstimation for the floor-to-floor height. Oh, hey, that's not bad. We actually got pretty close. I am surprised. That's not bad. Okay, so let's take a look at our heads-up display here. We do have our numbers. The next thing that we need to do actually is set the efficiency. Now this is probably not a very efficient building. The floor plate is not going to be like 90% efficient on this because the elevators are going to take up quite a bit of space here. So I'm going to say, I'm going to call it maybe 80%, 0.80. See how that works for us. And you'll see once we plug that in, our usable and our service square footage is all going to automatically be updated for us. You'll see these zeros turn into actual square footage. That's right, that's what we want to see. And all of these can vary too. Every floor can vary in its efficiency, but we're trying to work quickly here. So now we have our usable gross square footages for each of these elements. We have our estimated number of units for each, for hotel, for residential, and how it's kind of calculating that, as well as the parking ratios. That's looking pretty good. So, you know, I kind of like where that looks. Let's go and look at our presentation here, because this is a very extremely tall building. Just as you thought, you know, this is definitely screaming way off the page up here. So it's quite interesting to see actually. It's pretty fascinating. Yeah, that looks good as well. Each of these sheets shows different information. So for instance, this one's only going to show parking. It's jumping way off the page there. Let's just, yeah, the sections. So the good news is we have a vertically oriented presentation as well. Yeah, just like this. So this is our vertical 11 by 17 built for high rise. So you don't have to worry. And it looks like the scale is actually okay the way that this is set as the default scale. Maybe we want to rotate this. Yeah, we can kind of position that. The only thing is we, with all of these, yeah, this is listing out all of the square footages for all of the floors that we just did. And it's jumping right off the page here because it's so freaking tall. And you're not going to have this problem with most of the projects that you're doing. But you know, it actually doesn't look so bad. All of this information, we may want to change the scale of these sections. I'm going to kind of make this a custom, just so that fits on the sheet here nicely. See how that works. Yeah, that looks good. I'm going to do a little bit more because I'll show you in a minute here. Good. So we have a nice guesstimation. We came out to about 2,308,000 square feet. So that's interesting. You'll notice as well with this high rise, these sections are cut through here. You can move these sections up and down wherever you want. They correspond to the next sheets where we're showing the floor plans, as well as, again, all of the project data that you're going to want and need broken out different ways. So, you know, the idea is your client can ask for any sort of information and it's all going to be here. We haven't modeled or drawn any parking into here yet, so bear in mind that's something that this is capable of doing as well. So the next thing that I want to do here, just as a little experiment, I want to see what happens when we start messing with the uses in this. You know, this all was meant to be high-end residential here, so I'm actually going to, instead of just calling this generic residential, I'm going to say 4-bed, 3-bath. I'm going to be very specific about the residential 4-bed, 3-bath for this whole section here. And let's see, we wanted it to be not 14 feet, we wanted it to be 12 feet, there we go. Yeah, good. Okay, so that shows up a little bit of a different yellow, and that's going to show up in our schedule down here as well. But we really don't want to have 4-bed, 3-bath, and then also just say residential. So why don't we take another chunk out of here? We can kind of just take random chunks of this and say it's going to be 3-bed, 3-bath on that side. Good. Yeah, I really just want this to be kind of like a bunch of different. This is going to be smaller. The 2-bed, 2-bath. Okay. Yeah, that way we can kind of see. Yeah, we have all 3 of those out. And you know, the rest of this, we're going to make probably the higher end. 4-bed, 3-bath, 12 feet. That way we don't have any just generic residential up here. Yeah, okay. I like that. You know, I also want to change maybe these top, I think it would be really cool if these top floors up here was an auditorium instead. Imagine having an auditorium way up high like that. I think is kind of cool actually. So I'm gonna make that auditorium, and you know, maybe this over here is retail. I really think there should be some retail in this project. Retail. The client comes in and says, "Hey, what if we want to make this retail here? What's that going to do to our parking and our?" Yeah, that looks good. So once again, you're going to see all of that reflected here. You're going to see the percentages put out. You're going to see the number of units for each of these. You can go in and change these calculations, the way it's calculating. It's super easy how to do all of that. I'd like to see the uses diagram now with these different colors applied in the presentation. It does look quite cool, if I do say so. And actually, you know, we're still going to show residential here, so I'm going to change this to an auditorium down on the ground floor. Auditorium 15 feet. I'll be able to do it. Yeah, I like that. Okay. And you know what else? I kind of want this to be fitness. Let's see if we have a fitness at 30 feet. We do not. Yeah, not to worry. Not to worry. We'll make these our fitness. You know what? I'm just going to make a new fitness. And fitness in the project. And I actually updated it in this view, but I would prefer to have updated it in my heads-up display view, because now this view, I like to keep these nice and orthogonal. There, that looks good. And you can see our diagram is going to reflect all of that. And if you cut a section through that plan as well, you would see that show up there. So this is looking pretty good. So we have our efficiency set. We have all of this other stuff set. You kind of get the idea for how this is working. What I want to show is these 4 sample projects that this comes with. If you were to download this and get access to this file, you'll have access to, in the design options here, there's 4 different projects types, just to illustrate that this really can do any type of project. Here, let me set this back up. The way it comes out the box. So this is what you're going to see when you initially download the project, and you'll see that all of the information now reflects the current design option. So this is one sample project. If you go back to the presentation, it's going to look, you know, the way that we want to see it. The cool thing is we can really easily change this to a whole different project. You can actually do multiple projects, completely different projects, inside of this same template here. And what we do is change the scale of these views. So I want to change this maybe to 160, see how that works. Yeah, that looks good. I want to change the corresponding 3D. And you'll see that your data on the project matches. So this is, that last project was a mixed-use project. This is a single-family residential master plan project. And if you go back to the presentation, you're going to see all of this stuff is, you know, looking good. The floor plans are updated. All you really have to do is update all of your stuff in this main dashboard view here. So if we go back to our design options, I'll change it to this 3rd one. So far we have mixed use, and yeah, this is just a multi-family project here. And all I have to do is change the view. I think maybe 50 is, yeah, that's gonna fit in there nice. And you can see that if we go back again to our presentation, you don't have to touch it. It's already done. I've set it up so that everything scales the right way. There's about 1,000 different little things that I'm doing here that's making it nice and easy to scale all of this stuff. Now there's no basement on this project, but you may need to change the line work, and you know, you also kind of want to adjust the section cuts and the scope of the sections when you're changing projects. I'm going to show you this last project here real quick. Looks good, looks good. And one thing that I didn't really get to show just yet is the way that parking actually works. I'm going to show you that just really quickly. Cut through my basement parking here. In this design template, you'll actually get many different parking families, and it's super easy to modify these. All you have to do is grab these arrows and you can change the parking, and then as you do that, let's grab this one and stretch it out to there. As you do that, it's going to update your cars provided count. So you can always tell cars required based off of the massings that you're drawing and the cars provided, and you can try to balance your site that way. And before you even draw any of the parking spaces, because that can get tedious, your garage estimated is also going to be updated. So you'll get 90-degree parking, you'll get parallel parking, and you'll get 45-degree parking. It's really easy to change the size of the parking. You'll see how to do all of that. Once again, once you have access to this file, the link is in below, down below in the description of this video. And once you have access to the file, once again, you'll be taken to this site, siteplansshortcuts.com, which you'll have access to these videos once again, which explain to you step by step, very easy, how to do all of this so that you can follow along. You can also come up with your own projects. I'd love to see what you come up with actually. So that's it for me today. My name is Brent Abear. This is ATX Architect. Thanks, and I will see you in the next video.